In this section, we will be solving a few polynomial equations. Our first question is the following. We have to factorize x cubed minus x squared minus 65x minus 63. We can solve it in the following manner. Now, we need an x cubed term, so we multiply x plus 7 with x squared. We have x times x squared is x cubed, plus 7 times x squared is plus 7x squared. So that's x cubed minus x cubed. We have 0. Minus x squared minus 7x squared gives us minus 8x squared. We can bring these terms down. We have minus 65x minus 63. We need an 8x squared term, so we have minus 8x. That gives us x times minus 8x, so that's minus 8x squared, and minus 8x times 7, that gives us minus 56x. So that's minus 8x squared, minus of minus, that's plus 8x squared. You have 0. And then minus 65x plus 56x, which gives us minus 9x minus 63. We bring that down. We need minus 9x, so it's multiplied by minus 9. So that's minus 9 times x is minus 9x. And we have minus 9 times 7. That's minus 63. Now we just subtract. Minus 9x minus of minus, so that's plus. Minus 9x plus 9x is 0. And minus 63 minus of minus 63, so that's minus 63 plus 63. That's 0. So our final answer is this. So our polynomial can be written in the form x plus 7 times x squared minus 8x minus 9 equals 0. We know that x plus 7 is a factor of this polynomial. We can find the other factors from this quotient that we got. So we have x squared minus 8x minus 9 equals 0. So that's written as x squared. We can split the middle term as x squared minus 9x plus x minus 9 equals 0, which can be written as x times x minus 9 plus 1 times x minus 9 equals 0. We have x plus 1 times x minus 9 equals 0. So the other factors we have are x plus 1 and x minus 9. Our third factor was given in the question. The roots of the polynomial is given by minus 1, 9, and minus 7. For our second question, x equals minus 1 is a root of, we have to show that x equals minus 1 is a root of this polynomial. So to do that, we can substitute minus 1 in this equation, and if it in this polynomial, and if it is equal to 0, then it is a root of that particular polynomial. So we have minus 1 cubed So we have minus 1 cubed plus 11 times minus 1 squared plus 31 times minus 1 plus 21, which gives us minus 1 cubed is minus 1 plus minus 1 squared is 1, so that's 11. And 31 times minus 1 is minus 31 plus 21. This gives us minus 10. That gives us 10. So 10 minus 10 is equal to 0. Hence, x equals minus 1 is a root. Now to locate the other roots, we can consider x plus 1 as a factor of this polynomial, and we can follow steps which are similar to the previous question. We can divide x plus 1 with the following polynomial and find the quotient, equate it to 0, and find the other factors. Here we need an x cubed term, so we multiply x plus 1 with x squared, which gives us x times x squared is x cubed, x squared plus 1 is x squared. We have x cubed minus x cubed is 0. 11x squared minus x squared is 10x squared. We can bring the rest of the terms below. Next, we need an x squared term or a 10x squared term, so that is done by the following method. We can multiply x plus 1 with 10x. So we have 10x times x, that's 10x squared, plus 10x times 1, that's 10x. We subtract. 10x squared minus 10x squared is 0. 31x minus 10 is given by 10x is given by 21x plus 21. We need 21x, so we multiply x plus 1 21, and that gives us 21x plus 21. We subtract it and we get 0. 21x minus 21x is 0, and 21 minus 21 is 0. So our polynomial can be written as so we have x squared plus 10x plus 21 times x plus 1 equals 0 gives us this. So we can find the roots for this equation by equating each factor to 0. So we have x squared plus 10x plus 21 equals 0, and we have x plus 1 equals 0. This is already given in the question, so we have x equals minus 1. And for this, we can split the middle term, and that is done by, we have 3x plus 7x plus 21 equals 0. So we have the product, which is 21, and the sum is 10. The factors of 21 are 7 and 3. and 21 and 1. 7 and 3 give the following sum. It gives us 10. So the middle term can be split with 3x plus 7x. And we can further simplify it as so. Gives us x plus 7 and x plus 3. We can equate each of the factors to 0 to find the root, which gives us x plus 7 equals 0 and x plus 3 equals 0. That is x equals minus 7, x equals minus 3, and we have x equals minus 1 from the question. These are the three roots. For the next question, it's similar to the previous one. We have to show that x equals 2 is a root of this polynomial, and we to locate the other roots. To show that x equal to 2 is a root, we just substitute it into the left hand side of the equation. We have 2 cube minus 3 times 2 minus 2 equals 0. Minus 2, which equals 8 minus 6 minus 2. This gives us minus 8. So 8 minus 8 equals 0. And this shows that x equals 2 is a root. Next, we have to find the other roots. We can do this by considering x minus 2 as a factor from this equation and dividing the polynomial by x minus 2. We need x cubed. We multiply x minus 2 with x squared. So we get x times x squared is x cubed minus 2x squared. Subtract it. And we get x cubed minus x cubed is 0. Minus 3x plus 2x squared. So we can write it as is. We can bring 2 down. Next, we need an x squared term. So we multiply x minus 2 with 2x. We get 2x squared minus 4x. So 2x squared minus 2x squared is 0. Minus 3x plus 4x gives us x minus 2. Next, we need x minus 2, which is this factor itself. So we multiply it with 1. And we get x minus 2. X minus x gives us 0. Minus 2 minus of minus 2 gives us 0 because it's minus 2 plus 2. So our polynomial can be written in the form of x minus 2 times x squared plus 2x plus 1 equals 0. We can equate each of the factors to 0 to find the roots. We already know that x minus 2 gives us x equals 2, which is given in the question, one of the roots. To find the other roots, we equate our quotient to 0. We can split the middle term. This is 1 is a product and 2 is a sum. The factors of 1 are 1 and 1. So we can split the middle term as 1x plus 1x plus 1 equals 0. We can simplify it further as so. Equating each of these factors to 0, we have x equals minus 1 and x equals minus 1. So these are the roots for the following question. You can do question 4 on your own. The solution will be given at the end of the video. Let's do question 5. We're given that x plus 1 the whole square is a factor, and we have to factorize this big polynomial. We can expand x plus 1 the whole squared. It gives us x squared plus 2x plus 1. I use the following formula. A plus b the whole squared equals a squared plus 2ab plus b squared. We can divide this polynomial with this, similar to the previous questions solved in this video. So to continue, we need x to the power 4. We have an x squared term, so we multiply this factor with x squared. Gives us x squared times x squared is x to the power 4. 2x times x squared is 2x cubed. 1 times x squared is plus x squared. So x to the power 4 minus x to the power 4 is 0. Minus 7x cubed minus 2x cubed is minus 9x cubed. 3x squared minus x squared is 2x squared. Next we need minus 9x cubed. So we multiply this with minus 9x. We have minus 9x cubed minus 9 times 2x gives us minus 18x squared minus 9x. We can bring the rest of the terms down. That gives us minus 9x cubed minus 9x cubed, that's 0. 2x squared plus 18x squared gives us 20x squared. 31x plus 9x gives us 40x, and that's plus 20. We need 20x squared, so we just multiply this with 20. We have 20 times x squared is 20x squared. 20 times 2x gives us 40x plus 20 times 1 gives us 20. 20x squared minus 20x squared is 0. 40x minus 40x is 0. 20 minus 20 is 0. Therefore, we can write this polynomial as x squared minus 9x plus 20 times x squared plus 2x plus 1 equals 0. We just have to factorize the question, the polynomial in the question. So for this, we can split the middle term. We can write it as the factors of 20 are 1, 2, 4, 5, 10, and 20. 4 and 5 give us 9. So we can write it as minus 4x minus 5x plus 20. And this is just x plus 1 the whole squared expanded. So we can write it as such. This can be simplified as x minus 4 minus 5 times x minus 4. And that gives us x minus 5, x minus 4 times x plus 1 the whole squared equals 0, which is the answer. Next, we have question 6. We have to use the technique of equating coefficients. For this, since it's an equation raised to the power of 4, or with degree 4, it has 4 roots. 2 of the roots are same. We can write it in the following format. Where minus alpha of the polynomial. This gives us x squared minus alpha squared from these two, using a plus b times a minus b equals a squared minus b squared. We can write this in a simplified form as x squared plus ax plus b. Expanding this gives us x to the power 4 plus ax cubed plus bx squared minus alpha squared x squared minus alpha squared times a times x minus alpha squared b. We can group up the like terms. This is our polynomial, and we can see that the degrees are the same. We can equate the coefficients of this x to the power 4, x cubed, x squared, x, and the constant. So the coefficient of x to the power 4 is 1. Coefficient of x to the power 3 is a over here and 3. For x squared, it's b minus alpha squared and minus 7. For x, it is given by minus alpha squared times a equals minus 27. And the constant is given by minus alpha squared b equals minus 18. We have the value of a. We can substitute it in this equation and we get minus alpha squared times 3 equals minus 27, which is also equal to, we can take off the negative signs from both sides and divide the whole equation by 3. So that gives us alpha squared equals 9. We can substitute this in this equation, which will give us b minus 9 equals minus 7, which can be written as minus 7 plus 9 gives us 2. So our equation, we can plug this, and this back into our initial equation. So we have x squared minus 9 times x squared plus 3x plus 2 equals 0. We can break this down further. It will give us, we can split the middle term for the second factor. We have x squared plus 2x plus x plus 2 equals 0. We have x times x plus 2 plus 1 times x plus 2 equals 0. That's x minus 3 times x plus 3 times x plus 1 times x plus 2 equals 0, which is our final answer.